Hi, everyone. My name is Paula Sanematsu. I'm a research computing facilitator with FASRC. My background is in computational science. I have worked in flow and porous medium with computational fluid dynamics, and I also worked on biophysics, modeling epithelial tissues during embryonic development. And today I will do the training session on installing and using software on the FASRC cluster, mostly on the Canon cluster, but everything that we talk here should be applicable to the FASC cluster as well. If you have any questions, feel free to interrupt me and ask a question. I will try to keep an eye on the raised hands, but sometimes I may not miss it, so feel free to interrupt me. And also Maggie is here to help me, I think. And so if you would like to ask a question in the Q&A, and then Maggie can ask me, that's fine too. An overview for today's presentation, why we moved to Rocky 8 and the software changes due to this operating system change, how we use software modules, how we install Python and R packages, how to use precompiled numeric libraries, software libraries, how to use Singularity, and installing software spec. And also, we'll briefly mention that you can also use the Open On Demand VDI portal for GUI apps. If you would like a graphical user interface, the Open On Demand is where you can get that. So why we moved to Rocky 8? Because CentOS 7, the previous operating system, it was the non-commercial version of Red Hat Enterprise Linux, RHEL. CentOS is being discontinued by Red Hat. New development has ceased at the end of 2021. So this brings potential security vulnerabilities, and it's also incompatible with new software. The Rocky Linux 8 is also created by the original CentOS developers, and a good portion of the HPC community is also adopting it. So this means that we have more community support for development. That's very important. So if we run into any issues, other people are trying to solve and also facing those issues. Some of the software changes that happened during the June maintenance. So most of the software built on CentOS 7 will not work. As some of you have already experienced, it will not work. A lot of the modules are gone. We only have basic compilers, basic libraries, and a few software. The reason for going away with a lot of the modules was because it was not sustainable for us to maintain thousands of packages. We had more than 6,000 modules. It's just unsustainable. So spec can be used for most software installs. Singularity containers can also be used. We also show how to use Julia, Python and Python packages, and R with and without spec. If you absolutely need CentOS 7 support, we have an option for that too, that I will demonstrate how to use the Singularity container that has the full compute node environment that we used to have before the operating system upgrade. For HelmMod, for the software modules, so that's when you do module load, we have basic compilers, GCC Intel, we have CUDA, we have some MPI libraries, OpenMPI, MPI-CH, Intel MPI. We have basic numerical and input-output libraries, GSL, HDFI, NetCDF. We have some common software packages such as Python, Lambda, R, PyCharm, VS Code, but customization will be left to the user through spec. We also have commercial software through modules such as MATLAB, Mathematica, Stata, SAS, Lumerical, Console, those type of software. So some of the software, the module basics, how you load a software is with a command module load. And if you don't include a version, it will load the most recent one. If you include a version, it will load the exact version that you requested. And here are some examples to load the GCC compiler, to load OpenMPI, to load NetCDF. And then you can list your modules with module list. So I'll demonstrate that. Is this big enough to see, I think? I hope. All right, so if you would like to do module load GCC. Oh, first let's do this. Module spider GCC is how you can search for modules. And then it will give you these options, 9.5, 10.2, 12.2. So if you do module load GCC, it will load, you can do module list. This is what loaded. So it loaded the most recent one, which is 12.2.0, and it also loaded its dependencies. You can do module purge to purge all your modules. So if you do module list again, you don't have anything loaded. If you would like to load a specific version, then you can do module load and the specific version, and that will this will load GCC 10.2.0 and its dependencies. If you would like to see what happens when you load a specific module, what happens to your environment, you can do module display and the module name, and you can see all of the environmental variables that is added to your environment. So all of these variables are added. So when you do I have any modules? Module list. Yes. So when you do, for example, which GCC, it's going to call this GCC that is located in this path. Again, if this is another example of how to find available OpenMPI modules, you can do, it is not case sensitive, so you can do module spider OpenMPI, and it will work. It will find the lowercase OpenMPI, so you don't have to worry about being case sensitive. All right. How do modules work? So I already demonstrated which GCC, which shows which GCC, where the path is, how it's loading. I will show you another example with Python. For example, if we have modules, let me purge the modules. So if we do Python 3 to see which version we have, you can see that we have 3.6.8. And if I do which Python 3, it will be in my users bin in the users bin directory. But if I do module load Python, it will load Python 3.10. So if I do Python 3 version, now I have 3.10, and this location is different. It's the one that we installed instead of being the system Python. Okay, next one. Oh, and how do the modules work? That's the same demonstration I did before. So you can also do with Python. If you do module display. But for the module display, you have to tell the exact version. And then what it's doing is it actually loads the Mamba Forge. So let's see what module display Mamba Forge does. Okay, so the Mamba Forge module, it includes all of these variables to your path. So when you try to use Python, all of these environmental variables are set. Okay. One important thing about module hierarchy is that some modules are only available if you load a previous module, which I will show you. We have an example here for. So if you would like, for example, module, if you search for HDF5, it will tell you you will need to load all these modules on any one of the lines below before the HDF5. So because HDF5 depends on these, you have to load not all of these. You have to load one of these, depending on the compilers that you want. If you want MPI-CH, you load this one. If you want OpenMPI, you use this line. If you want Intel, you use MPI-CH, you use this line. So it really depends on the compilers that you want. Let's say I want Intel and OpenMPI. So I would have to do module load Intel and OpenMPI. Then I can load module load HDF5. So now I have everything. But if I try to do, if I try to simply do module load HDF5, it wouldn't work because HDF5 depends on other compilers. So it needs these compilers in order to be loaded. Anyone has any questions so far? No questions? All right, I'll keep going. For Python, we have replaced Anaconda with Mamba Forge, because it's faster, more robust, and it's a cross-platform package manager. You can load Mamba using the module load Python, as I showed, and it will automatically load Mamba Forge. Or for Python 2, unfortunately, Mamba does not support Python 2, so that is still done through module load Python /2.7.16. And that will load Python 2. For Python programs, Mamba is a tool to manage Conda environments. So it's a package manager. Conda is a package manager, Mamba is a package manager, pip is a package manager. So Mamba uses the same commands and configuration options as Conda. You can almost swap the commands and it will work, but we recommend to stick with Mamba because Mamba is faster to install and better manages the files. So to create a Conda environment, let me clear this module list. To create a Conda environment, you need to you need to do module load Python, and then you can see that we have Python 3.10. And if you would like to create an environment that will create in your home directory, it will create in this path. .conda envs. You can do mamba create -n is for name, and you can choose the package name. Let's do training. You can put any name you want, a training session. And let's say I just want Python equals 3.11. And then it will create, Mamba will create an environment with Python 3.11. It does not need to create an environment with Python 3.10. It can create any version that you would like, as long as it's compatible with the packages that you're asking to install as well. So that will take a little while. It may take a little while. It's gonna take. And then you hit yes. And then if you would like to activate, you can use either Mamba activate environment name, or you can do source activate. If you would like to install an additional package, you can do Mamba install. Let me make presentation mode. You can do Mamba install package. If the package is not available with Conda or Mamba, it's okay to use pip. You can use pip install my package. And if you have any problems updating a package, it's recommended that you uninstall it and then try to install it. If you are done using your Mamba environment, you can do Mamba deactivate. Please note that if you try to submit a job using ASPatch and then the Slurm script, if you're inside a Conda environment, it will not work. It will fail. So you have to submit jobs outside of your Conda or Mamba environment. For optimal performance, it is recommended that you use prefix to create your Conda environment in a file system that is has better performance for a few reasons. One of them is that usually if it's a Holy Labs, this file system is located in Holyoke, whereas if you're installing your home directory, that file system is located in Boston. So every time you try to communicate from a compute node where your jobs are running, they're all in Holyoke, and your jobs are running and they want to do something with the packages that are located in Boston, located in your home directory, that can cause some latency. So for better performance, we recommend that you install packages in a lab share in Holyoke. And to do that, you add, oops, sorry. Press the wrong key. Okay, to do that, what do? You add the flag -- prefix and the location that you would like to do and the package list. And to create the environment, instead of doing the -n and name, you would do prefix and the path. And to activate, since it doesn't have a name, it only has a prefix, how you activate is Mamba activate and the path that you chose to install to create the Conda environment. For R packages, when loading R from the LMOD system, the hell mod with the module load R, only basic R packages are loaded to your environment. Now it is optional to set rlibs user. Before we recommended that you always set it. You don't need to set it anymore. If you don't set it, the default location is this one, depending on the R version that you have. For R packages that require additional software installs, for example, GLMnet, SF, raster, we recommend R packages with spec, which I'll get to it after I talk about spec. So for example, if you would like to use R from the command line. If you're not using RStudio Server, if you're using R from the command line, you would do module load R. And this is the only version we have. Also, if you would like an older version, you would have to install it with spec. And then this is optional. You can set Artlib's user to a specific path that you prefer in your home directory. You would start R and then just install packages and whatever package you would like to install. Let me see. So now, yeah, now the Python, the Conda environment is done, and then to activate, you can do, it tells you what to do. Mamba activate training session, and then what you would see here is that when you're inside a Conda environment, it's in parentheses ahead of your prompt, and you can, if you do now which Python 3, you can see that it was installed inside. It's no longer the one from the module. Now it's from the training session environment. And if you do Python 3 version, you can see that it's 3.11 as requested. All right, sorry to go back and forth. No, my packages for Julia. For Julia, we recommend that you install it yourself, because when you install it yourself, you can better manage the packages and inside Julia. It is fairly simple. You can install wherever you would like. We recommend, again, a lab share in Holy Labs because of the better performance. And then you download Julia, you untar it, you extract, you export the important thing is just to add this path to your path. So when you type Julia, the command is recognized, and we have, let me copy this. We have documentation, detailed step-by-step documentation on how to, if you go to our GitHub, Julia, we have step-by-step documentation on how to install it if you would like to do. And I'll post this presentation as well online. How could you access the package in a script that is not housed in your home directory? I don't fully understand your question. Can you elaborate your question, please? Sydney, you there? Oh, how much does package location matter for the running script? Oh, that's hard to tell without knowing how much your script communicates with the home directory. I know it's better if you have if you install packages in Hollyoak, in a location that it's in a file system that's in Hollyoak, but I don't know. That is very dependent on what you're doing. Do you need to reference the package location? If you created a Conda environment, and you sourced that environment, you do not need to tell the location. You tell the location when you source it. When you do Mamba activate, it doesn't matter if the environment is in your home directory, like mine is. You can see mine is in the home directory. But if you had done Mamba activate and a path in Hollyoak, then the Python, when I would do which Python, it would be located in Hollyoak. So you don't need to specify anything else. That's how you tell. That's how you tell that it's located elsewhere. and you don't need to do anything in the import statement in your code. I'll keep going if you don't have any more questions. Singularity is a container software. It provides a container runtime and an ecosystem for managing images that is suitable for multi-tenant systems and HPC environments. In contrary to, for example, Docker is not allowed on HPC systems because it requires pseudo privileges, and that is not allowed in multi-tenant systems. Some important aspects is each application will have its own container. Containers are not fully isolated, so you can use the host network, you can use file systems, you can use your home directory, you can use Scratch. Users have the same user ID and the group ID when running the application. And you can build containers from an existing Singularity C container library, or from Docker Hub or NVIDIA or any other libraries. You can build from Singularity the definition file on the Scilab's cloud, and new after the Rocky 8 transition, you can build a Singularity container using a definition file and proot directly on Canon. Before this upgrade, you would have to have root access in another machine to build a Singularity image. You can pull images from different repositories. So what you should always do, you have to be in a compute node. So you request an interactive job. You can change to your Scratch directory and then pull a Singularity image. In this example, it pulls a Docker image from a TensorFlow from Docker Hub, or you can pull from Scilab. This is an Ubuntu image. And you can also pull from NVIDIA. So it would be Singularity pull doc. It's from Docker, but it's the NVIDIA channel group. I don't know how they are defined. And I will show one example. I won't do the whole thing because it takes a long time. Let me just remember deactivate here. Okay. So I'm already in a GPU node because sometimes it takes a little while to get. So what you would do is do Singularity, and then the command pool name is the name of your image, and the TensorFlow image that I would like to get is the TensorFlow 2.13, the GPU kind. There's also a CPU kind. And well, I'm doing the home directory, but I should have been doing in the Scratch. You can also search for different versions. This is hub.docker.com. You can look for TensorFlow. So this would be the TensorFlow community. And you can look for different, if you want a specific version, you can look in the tags. You can click on tags and see the different versions that they have. So they have the nightly build. They have with Jupyter, they have 2.13. And if you want something older, you can try them. So this is 2.12. And you can go further down and see if you would like something, a specific version. Okay, and this is how it looks when you're trying to get an image. This is going to take a while. I just wanted to show how it works. Eventually, you can, once you have the image download, it will download to your Scratch directory or your home directory. And you can, if you'd like to run an example, what you do to run Singularity with GPU. One, you have to be in a GPU node, and two, you have to use the --NV flag. This will use the GPU and you can run a code. So Singularity execute is to execute, and this is the command that is doing, it's running Python, and this is the code that is running. It's running mnist.net.py that it was downloaded from the Keras GitHub. To build your own Singularity images on Canon, first you need to set up proot in your home directory. You create, if you don't have it, create the bin directory. Then you download proot. You download proot from this address. You change the permissions for proot so you can execute it. And then you can build a Singularity image with the command Singularity build. This is the name of the image that you would like to build. And this is the definition file that you're using. And the definition file is in our GitHub page. Let me show you. It's in, so thinking to the wrong place. Oh, this is how to build a Singularity from definition file. So it's the whole thing, not just the definition file itself. Sorry. Yeah, so this is how to build a Singularity image with the definition file, but the definition file here is a little different than what we have in the presentation. All right. This is the definition file that we're using that you can try to build a Singularity image. It will install, this will be the base image. You use TensorFlow 2.12.0, the GPU kind, and then you're also installing these packages using pip inside the container. So these packages will be available inside the container. Now installing software with Spec. So Spec now is our main package manager to install software that used to be available with modules and are not available with modules anymore. So there is a one-time setup that you need to clone Spec repo into your lab storage. Again, we recommend lab storage because it's better performance than home. After you download, you source Spec, and then you install packages with Spec. Note that some some packages can take a few hours to build and also can demand quite a bit of memory. So I would recommend that highly recommend that you request an interactive job with 12 to 16 gigabytes of memory and also a few cores, because Spec can parallelize. So the installation will be quicker if you request more cores. And then for job submission, you source Spec, you load packages, and then you run your code. So for a one-time setup, again, this is how you request an interactive job with 8 cores, 4 hours, and 12 gigabytes. For this example with J-Harvard, we are using the Holy Labs directory in Holyoke. You clone the GitHub, you clone the Spec GitHub repository. And then you change directory to Spec. You check out the release, and then this is how you source Spec, either dot and share, or you can use the word source instead of dot. If you would like to install the most recent version, you don't have to specify a version. you can just do spec install bzip2. If you would like to a specific version, you do spec install bzip2 and the at version. And if you would like to be even more specific, you can do spec install. This is for another package, zlib2, zlib, and then version, and then percent the compiler at version. So this is specify not only the version of the package, it also specifies the version, the compiler, and the version of the compiler. I had, okay. So here I had a job running to show you how you can see. So to see the installed packages, you can do spec find, and it will list, now it will list a lot because I had a few. But you can see that I installed bzip2 at 1.0.6 and 1.0.1.0.8. So if I would like, I did the 1.0.6 by using this command. Instead of using 1.0.8, I did 1.0.6 and then installed the specific version that I wanted. So now if I want to load spec load bzip2, it will give me a conflict because now I have two options. So I have to tell which one I want. So if I do this spec load bzip2, now you can see spec find loaded. Then now you can see that I loaded the right package, and you can tell which bzip2, and you can see that this is the it is located in the Holy Labs. It is GCC 12 bzip2 1.0.6. Fine, I load it. Oh, and then if you want to unload your packages, you can do spec unload. And if you do spec find loaded, now I don't have any loaded packages. You can see a whole list of packages from spec in this page. And there are lots of them. I think the easiest way is just to, oops, it increased too much. You can just do Control F and then look for the package that you want. I think that's the easiest way to find. If you would like Python packages, we do not recommend using spec. For Python packages, we recommend Mamba, even though there are certain Python packages on the spec list. If you would like to share your spec install with group members, and you would like to have your group members install packages as well, you have to change the permissions in the packages.yaml file. If this file doesn't exist, you can create it. You can create one. It should be located in the etc/spec in this directory here. Oops, I'm already here. So normally you are in this spec environment, so you change to etc spec. And if it doesn't exist, you can create the packages.yaml file and include these permissions so other people, other lab members can install packages as well. Canon has heterogeneous architecture, so some nodes have certain types of CPUs, other nodes have newer CPUs where it's not completely homogeneous. So and a spec is architecture dependent. So if you would like to have a more generic flag, you can set the target to be this instead of being specific to, for example, Sky Lake or Ice Lake or Cascade, because spec can detect the architecture that you're installing packages. If you would like to add additional compilers, by default, we have GCC 8.5.0. If you would like to add the newest GCC, you first load the module GCC, then you run the command spec compiler find, and then it will add GCC 12. And if you do the command spec compilers, you should see the GCC 12 as an option now. And you will also need to modify this file that is located in your home directory. If it doesn't exist, you can create it. And the important part is to add these and also add modules GCC 12.2.0. So it will know where all the packages are located, where the GCC compiler is located. If you also would like to configure MPI for spec, you have to do a similar approach. You load GCC 12 and open MPI. You find where MPI is located. You add that to the .spec packages YAML file, and you tell where OpenMPI is located, and you have to specify that it's OpenMPI, the version that you have, and the compiler that this OpenMPI is compiled with. So this is an example on how to build HDF5 version 1.12.2 with GCC 12 and OpenMPI 4.1.4. After doing all of this, do a module purge, and then you do spec install with HDF5 specific version at %GCC with a specific compiler and specific OpenMPI compiler. So this, when you do this, it will be using the OpenMPI that you specified in packages.yaml. For R, if you need any of the packages that are, let me see. If you need any of the packages that are listed in our packages with spec, if you need GLMNet, raster, RGDAL, RGEOS, RSTAN, Surat, or SF, or if you want specific versions of R, older versions of R, we recommend that you use spec, because all of these packages require software installs beyond R package. So you actually need to install other packages on the background, and spec does that for you. So you request an interactive job, because spec can take quite a bit of time and resources. Choose a lab share, source spec, and then you install. The R packages are usually R dash and the package name. So it would be spec install R, RGDAL, and then if you would like to use it, spec load R, RGDAL, you can launch R, and then you simply load the library. You don't need to install. You don't need to do install packages RGDAL. It will be already installed with spec. So if you would like to submit a Slurm job with spec, here are the usual Slurm directives that we have. But the additional step that you need is to source spec. You have to tell, it's better to have the entire path. You can substitute a dot with the word source. You have to load each package that you need. And then, let me rephrase this. You have to load each package that you need, as long as it's not a dependency. If, for example, if there is a package that is a dependency of Artera, if you do spec load Artera, it will load Artera dependencies. And then to run, you can simply use the code that you used to have before. The important part is to source spec and to load the packages. If you absolutely need the CentOS 7 support from the before the upgrade, you can use a Singularity image that we have available for anybody. It is located in this path, Singularity image, FAS CentOS, and it's also in our documentation. If you go to FAS github.com, let me go again. github.com/FASRC. You go to user codes. You go to Singularity containers. It's a little cut off. Go to CentOS 7, and we have all the instructions here on how to run Singularity, how to load modules, submit Slurm jobs. If you would need to add packages to it, how you can modify the image. And here is just a very short summary of what's that documentation. So module load GCC, it will load the modules it will load CentOS 7 modules. It will not load the modules that you have on the cluster right now. So you can do module load MATLAB. Oops. And then if you need to execute a job, you would have to refer to this doc to see how you would do Singularity run, and then the Singularity image. If you would like to run a script, you have to, so the run command will run a script. If you would like to execute, if you would like to have those commands inside your script, your Slurm script, then you can have run the name of the Singularity image, and then you can have the load modules, compile code, and execute code in between the end flags. Finally, we also have Open on Demand. So if you would like to go to Open on Demand, it's rcood. I blanked. .rc.fas.harvard.edu. You have to be on the RC VPN. You have to type in your password. And you can use these that will provide a graphical interface for you. So you can do, this is the same thing as you're submitting a job. You have to request a partition, memory, CPUs. If you like a GPU, I don't want a GPU. Time, and you can choose the version. This is for specifically for R, but these the forms are very similar for different applications. And then you can, once the job gets through, it can take a few minutes. And you can launch the job. This is taking awfully long, but this is this would be the R Studio. We have other options with remote desktop, Jupyter Notebook, MATLAB, Stata. So this is our Studio interface that you can use. And to install packages here is much easier. You just do, it's too small, install packages, and you can do, for example, data.table, and it will install. You don't need to set RLibs user. You don't need to do anything. We recommend, unless you need to do from command line, we recommend that you use our studio server because it's a lot easier than installing packages from the command line. If you have any questions, we have our docs. We have a Rocky transition guide for the changes that I mentioned here and more in the transition guide. If you need help, you can submit a ticket via portal or email. We also have office hours every Wednesday from noon to 3. And we also have more trainings coming up if you're interested. I'm open for questions if you have any questions.